In this tutorial, we'll be starting to use non-ideal data and use measures of similarity to search for values of interest. Suppose we have an image and we're interested in finding a pixel with a particular value. In this case, we'll suppose we have a matrix and would like to find the element of the matrix that's closest to the number 42. We can't be assured that the matrix contains the number 42 exactly, so we need to use measures of closeness to find the one that's the closest to the number we're after. So we're going to introduce squared error as a measure of similarity. So that's the same as subtracting the number we're after off every element in the matrix, and then squaring every element, and then the number that's closest to 0, or the number that's lowest, is going to be the value that's closest to the number we're after. So we've turned a problem of finding a number that's close to another one into a problem of just finding the lowest value out of a set of numbers, which we already know the Matlab functions for. So if we have this matrix here, 6, 8, 5, 3, and we'd like to know which number here is closest to the number 7, we can subtract 7 off every number, and then we'll square every number in the matrix, and then we end up with the matrix 1, 1, 4, 16. So the lowest values in this matrix were the numbers in the original matrix that were closest to 7. So 1 and 1. So 6 and 8 were the closest numbers to 7. And there's the Matlab code there as well. Just put a full stop before the power operator, and then instead of multiplying the matrix by another matrix, it squares each element in the matrix. So in this tutorial, we'll be using basic arithmetic and element-wise operations of the type of operation we just talked about, and we'll be finding minima in a set of data. And then we're doing some more advanced plotting and using more advanced data structures. In this tutorial, we'll be using test data for analysis. We'll use squared error as a cost function, and we'll exhaustively search the image, which just means searching the whole image for an optimal solution. And then we'll plot circles at the solution, just like we did in the last tutorial. And then, as always, we'll produce a quality plot for exporting. Let's get started in Matlab. What we've got sitting here to start with is content that we've covered before, setting up some plotting things, generating some fake data, and then plotting it using imshow. So we've covered all this before, and we're not going to cover it again. We're just going to head straight into the new stuff. So the objective in this tutorial is the same as the last one. We want to find a value in a matrix that's close to a particular value. This is analogous to finding the character that's closest to Wally in a large image. But this time, our data is a little bit more realistic. Last time, we were guaranteed in our pretend data that exactly one pixel was equal to the one we were looking for. But now what we have is a randomly generated image where we can't be guaranteed that the image contains the pixel we're looking for. We also can't be guaranteed that there's just one. There could be multiple. So what we'll do is, instead of searching our data image for the value that's closest to the number we're after, 42, we'll turn this into an equivalent problem that we solved before, which is finding the lowest value in a matrix. So we'll just define the new matrix F, which we'll be working with, and we'll use squared error. So we go image minus the number we're after, num to find, and then we'll square every element in this matrix by using dot squared. Now if we run this, we have one little problem to solve first. Our matrix image is an unsigned 8-bit integer, like all image data that we'll be working with. But now that we're doing operations with it that aren't just plotting it as an image, we need more numerical precision. We need more than just integers. So what we should do is tell Matlab that we explicitly want to deal with doubles with more precision. And this problem arises from this data image being an unsigned 8-bit integer. This means that it can only hold values between 0 and 255. So for example, if we have the the variable a, which is equal to 5, but it's an unsigned 8-bit integer. If we go a minus 10, we'd expect to get minus 5, but instead we get 0. And likewise, if we go a plus 300, we would expect to get 305, but we get 255. So when dealing with this data type, it caps out at 0 and 255. So we need to be very specific and tell MATLAB that we don't want this to be an unsigned 8-bit integer anymore. We want it to be a double, which has lots of numerical precision. So now if we run this, we should have solved that problem. Looks like we have. So now the first thing we should do now that we have this is plot it so we can see what we're dealing with. Now we still want to plot this like an image because it's still something that's evaluated on a discrete grid, but it's no longer a valid image. So we shouldn't plot it with imShow. It's kind of like a scaled image, and MATLAB has a function for that called image_sc, meaning image scaled. And instead of calling this pattern, we'll call this cost. Now if we run this, oh, I've accidentally overwritten figure 1. We should use figure 2. There we go. So now there's a couple of things to fix. One thing is, if we change the size of this figure, MATLAB will allow these pixels to elongate and change shape. What we should do is tell it that we explicitly want an aspect ratio of our data of 1 to 1 on all axes. So now if we run this and we start changing this figure around, the pixels stay square. Another thing we'd like to know is what each of these colors means. MATLAB has a function called colorbar, which will display a little legend on the side telling us what each color means. So here blue is lower and yellow is higher. So the bluer a pixel is here in figure 2, it means that the closer the corresponding pixel is in figure 1 to the number we're after, 42. But now what we'll do is, instead of just finding the lowest value in that matrix, we should find several of the lowest values and return them all. So here's the reason. When we go to find Wally in the future tutorials, we can't be guaranteed that the Wally that minimizes our cost function is going to be the real Wally. It could be a very convincing Wally lookalike. So we need to be very careful. And what we should do is just produce, say, 10 of the most likely results and give them all to the user so the user can make up their own mind. So what we're going to do is, instead of using MATLAB's function min, which just finds the single minimum value, we're going to use MATLAB's function sort, which will sort data into ascending order. So if we call sort f, what it does is sorts all the columns of the matrix F like this, but what we really want is we want all of F sorted. We can make use of the colon operator to collimate our data. So if we call our variable F with the colon operator after it, what we get is we get F as it was, but squeezed into a single column. And then we can sort this. So we can go sort F. So sort actually tells us two things we need. It gives us a sorted version of our data, and it'll also tell us a list of how that data was rearranged to make the new one, the sorted version. So what this tells us is, we'll sort F, and it'll tell us how F was rearranged to make V, which will be a sorted version of the data. So V is just F in ascending order. And what this tells us is that the 105th element of F is the lowest one, which also means that the 105th element of our image is the one closest to 42. So let's just go ahead and plot one circle around the top result, and then we'll go ahead and plot more. We're going to make use of our function createCircle, which we created in a previous tutorial, to plot the results. So we'll use a radius of 1. What we need to find the center locations here. So to convert this index into a sub-index to get an x and a y center location, we'll use Matlab's function end2sub, which we've used before. We need to tell it the size of the matrix we're dealing with, and we need to tell it the index we're after, which is the first one. And this will return the y center location and then the x center location. Okay. And now we should just use Matlab's function plot to plot the circle data. Now if we run this, what we get is a circle plotted around the element 5, 11. Now we can use our data tip tool here to click on this and inspect it. So this index 0 is telling us that the value of this pixel in this matrix, or the value of this element in this matrix, is 0, which should mean that the element 5, 11 up here is exactly 42, which it is. So this appears to be working. What we should do now is put this in a for loop and plot, say, the first 10 results. So if n equals 10, we should say for I equals 1 to 10. And we just need to replace index 1 with index I so that it works up the list. Now we should have 10 circles plotted around the 10 pixels here with the lowest values, which are the 10 pixels here closest to 42. But these colors don't really mean anything. What we should do, or what we could do, is we could choose to plot the top 3 results in green, and then after that we could plot the remaining 7 in red, just so we can tell which ones are the most likely solutions and which ones are less likely. So we could use green here, and then we'll get green circles if we use a G, and if we put an R there, we should get red circles. So let's do this. If I is equal to or less than 3, then we will plot a green circle by changing that to a G. Otherwise, we will just plot a red circle. Now here's a Matlab tip. When you have for loops within for loops, or if statements within for loops and vice versa, it's much nicer to read and easier to understand if everything is indented correctly, which just means it's shifted over when it's inside the loop. So if we highlight all this code here, and you press Control-I or Command-I, depending what OS you're on, Matlab will automatically indent the code for you, so it's much easier to read. So every time you go a level down, it tabs across again. So now if we run this, yep, we should have 3 green circles plotted around the 3 most likely values, and then red circles plotted around the remaining 7. In the next tutorial, we're going to do more image processing now. So instead of looking for pixels, we're going to start to look for objects.